Welcome, Algebra 1 students, to Unit 1.3, the properties of real numbers, focusing on addition. You are hearing the voice of Mr. May, and I will be guiding you through this lesson. And as always, please make sure that you have your guided notes. We will be completing those as we proceed through the lesson. And so let's begin with our learning targets. The learning targets, we have 5 of them, and each one of them is going to use the verb use. I can use the commutative property. This is learning target 1.3a, the commutative property of addition to add real numbers. Learning target 1.3b, I can use the associative property of addition to add real numbers. Learning target 1.3c, I can use the identity property of addition to add real numbers. Learning target 1.3d, I can use the inverse property of addition to add real numbers. And finally, learning target 1.3e, I can add real numbers with the same and different signs. The first 4 of these are properties that become especially important as we move into both simplifying expressions and solving equations. These are the whys that allow you to justify your steps in each one of those processes in either simplifying an expression or solving an equation, and you will see these reappear throughout your algebra course. So this is a very important lesson to pay attention to and truly understand the concepts that are involved. So let's begin to see how we can use all of these properties, but to be able to use them, we must understand what they are. So let's consider 3 plus 7. If you take a moment and look at that, you'll probably relatively quickly realize that 3 plus 7 is equal to 10. Looking to the right, if you notice, we have 7 plus 3. And as you probably have already determined, it is also equal to 10. Below that, we have 6 plus 14. That is equal to 20. 14 plus 6. That is also equal to 20. And what this is doing is this is actually introducing us to terminology that we already know how to use in practice. We use this. It's just now understanding the terminology and a property that allows us to realize and actually compute 3 plus 7 is equal to 10, but it does not change for 7 plus 3. And so that property is actually the commutative property, which we will see on the next slide. The commutative property of addition. Notice, first of all, the commutative property is for addition, not subtraction. So on the previous slide, if you recall, we had 3 plus 7 is equal to 10. 7 plus 3 is equal to 10. That works for addition. However, 3 minus 7 is equal to negative 4. And 7 minus 3 is equal to positive 4. Not the same solution. Therefore, we have to make sure that we really focus on the commutative property is for addition only, not subtraction. And so looking at the commutative property, what this is saying is that the order of the terms can change, but the value of the solution or the result does not. And think of it, and if you need to kind of remember commutative property, okay, the name commutative, because it's going to be important that you remember the names of these properties and what they actually are referring to within an equation or an expression. And so the commutative property I like to use the analogy of commuting to work. And for example, if I were to begin here in Danville, if I live in Danville and I drive my car, let's do a truck instead. So I'm going to drive a truck to Lexington. Let's give it a little windshield here. And I'm going to drive my truck to Lexington to work. That's my commute. Okay? And that is about 42 miles. Okay? So I'm commuting 42 miles. Now, at the end of the day, when I want to go home and I want to drive back to Danville, I'm not driving a negative 42 miles. I am still driving 42 miles. It doesn't matter the order of my commute, the value of this 42 miles does not change. It stays the same. And so that is what we can also think about as we look at the commutative property inside an equation or an expression. In this case, we have an equation. Okay, and in this equation, we have generalized it using variables. We have a variable A and we have a variable B. And what the commutative property says is that A plus B is going to be equivalent or equal to B plus A. Nothing changes as far as the value is concerned. And so when we look at why the name commutative, we've already discussed that. That is very similar to thinking about the commute to work. And so we can kind of think about our analogy with commuting. And then if we were talking about examples, we had examples on the previous slide, but if we were to make up our own examples, we could use any number. We could use 3 plus 1 is equal to 4, and 1 plus 3 is equal to 4. We could use 7 plus 6 is equal to 13, but 6 plus 7 is also equal to 13. We can have many different examples that basically says if the order of the terms change, the value does not. So that is the commutative property of addition. Next, let's consider this. If we use parentheses being grouping, so we've grouped the 5 plus 4 in this case, and then we've added the 10. So 5 plus 4 is 9, plus 10 is equal to 19. And if we look over here, notice that the grouping has changed. Our grouping at this point is the 4 and the 10. So take a moment and think about, has anything about the value of that expression changed? And if you were to use the order of operations, in this case, parentheses first, so 4 plus 10 is 14, plus the 5 is still equal to 19. So although our grouping did not change, or did change, the value did not. Let's look below. Does it work even with larger numbers? Well, our first grouping in this case is the 12 plus 18. That is equal to 30. 30 plus 100 is equal to 130. In the second example, we look over here. Notice we still have a 12 plus an 18 plus a 100, but the grouping has changed once again to the 18 plus 100, which if we were to add those together, it would be 118 plus 12. That is also equal to 130. So take a moment, think about what's going on here and how this relates to your working of, in this case, expressions or equations. And you're probably somewhat familiar with this, but now we are going to give it a name. And we're actually going to give it a property name. And that property name is the associative property. So looking at the associative property, once again, I want to highlight it is the associative property of addition. This does not work with subtraction. So we have to be adding for this property to hold. And so when we look at the associative property, what this is stating is that the grouping of the terms changes. So we're changing the grouping. And whenever the grouping changes with addition, the value does not. So once again, we're generalizing. A is one of the terms represented by the variable A. We have a second term, and it is grouped with that A. However, on the other side of the equal sign, the second term B is grouped with C. And so what we are able to recognize through the associative property is that despite the change in grouping, the value does not change. And so we can think about it when I look at why the name. I tend to use the analogy of who we associate with, our friends. And so let's say, let's go make a little arrow down here. Let's say you have, 3 or 4 friends that are just kind of hanging out, and they're in a group, right? And so there's 4 friends, right? And so these 4 friends right now, they are kind of in groups of 2, right? So there's still a total of 4 friends, but right now they're grouped 2 by 2, right? They're just carrying on a conversation with each other. But if I were to regroup these because they're all added together in a group of friends, if I were to say, all right, let's, have this guy and this guy hanging out, and actually, you know what, let's distinguish them. Let's give this one wearing a green shirt, this guy's wearing a green shirt, pink shirt, and let's see, we've got a yellow shirt, and we need a different color. I can wear a blue shirt. All right, so let's change the grouping. So now we got the green shirt talking to the yellow shirt, and we're going to have the blue shirt talking to the, looks like the pink shirt, right? So let's draw my final friend out here and give them a pink shirt. So even though the groupings of our friends have changed, there's still 4. The value of them hasn't changed. The total number hasn't changed. So despite how they're presently associating with, the value or the total number of friends that are hanging out has not changed. And so that's how you could remember the name associative property. Now, examples, I'm going to give you an example. See if you can think of one on your own. Take a moment, hit pause. See if you can think of one on your own. And now that you've come back from hitting pause with an example of your own, I am going to just give a simple example here. Let's say 1 plus 3 plus 4 is equal to 1 plus 3 plus 4. And just to kind of relate it to the example that is generalized, so we have our 1, okay, similar to our A term. We have our B, and then we also have there could be a C term. And if we were to evaluate both sides, we would have 1 plus 3 is 4, plus 4 is 8. And then we have 3 plus 4 is 7, 7 plus 1 is 8, 8 equals 8. So although the grouping changed, the value did not. Okay, let's look at another set of examples, and probably you have already looked at each one of the, in this case, we're going to say equation because there is an equal sign, and you've probably already determined what the answer to each of them might be. 5 plus 0 is 5, 12 plus 0 is 12, and negative 3 plus 0 is negative 3. And so if we were to attempt to describe the behavior of these equations, what might you conclude? Take a moment to think about it. And more than likely, your conclusion is that whenever you add 0, notice that 0 is the common term in each one of these. Whenever you add 0 to something, you get whatever that something is. The value does not change. 0 does not change the value. That is relatively straightforward. You've been using this for quite some time in your math classes and probably everyday life. And now we're actually going to learn the property that describes this. And the identity property of addition is what actually describes the fact that the sum of a number, again, we're talking about addition of a number, and 0 is the number. And so whenever you have a number and you add it to 0, you end up with whatever that number is. And once again, we have generalized it here, where a plus 0 is going to be a. You can substitute any value in for that a. A is just a variable. It's a placeholder at the moment. You can substitute any value there. Same for b plus 0 is b. And finally, c plus 0 is c. So let's think about why the name identity. Take a moment. Why might this be called the identity property? And you may conclude that it's called the identity property because, and I'm actually going to work this through the example. I'm going to work the why the name through the example. At the moment, if we were to have an example of 10, the identity of 10 is its value. Okay, we give the number 10 its identity through the value that it represents. And that means 10 of something, 10 fingers, 10 toes, 10 songs in your playlist. It could be a lot of different sets or groupings of 10. It's a value, but that's its identity. And the reason that we call this the identity property is because although we add a value to it, in this case 0, the identity of our original value, the identity of that 10 does not change. It maintains its identity. It maintains its value. And so we could have any number of examples. 3,175 plus 0 is equal to 3,175. You can come up with some examples on your own, but importantly, you need to remember that 0 does not change the identity of the number that is being added to because it maintains its value. The original number maintains its value. Take a moment now and consider these three equations. And so, what is going on here? Well, if we have -6 and we add 6 to it, and I like to think of it this way. If I owe you $6, if I borrowed $6 from you, borrowing $6 from you is pretty much the same as being -$6. I'm down $6. But if I pay you back $6, right, that's giving you back, adding that $6 back to your bank account or your savings account, how much do I now owe you? Well, if I borrowed 6 and I paid back 6, then at the moment I owe you $0. So let's look at the next one. If I borrowed 20 and paid you back 20, how much do I owe you? Well, $0. And I bet by now you can see the pattern. And despite the fact that we have changed the order of the positive being the first term instead of the second term, if I were to, in this case, loan you $3 and you were to pay me back $3, you would still only owe me $0 in the end. And so what we are seeing here when we describe the behavior is that when you take a number and you add its opposite. Now, when we use the word opposite, opposite refers to the sign. So the opposite of a positive 6, the opposite of a negative 6, negative 6 in this case, is a positive 6. The opposite of a negative 20 is a positive 20, and vice versa. The opposite of a positive 20 is a negative 20. And then finally, the opposite of a positive 3 would be a negative 3. So when we are adding the opposites, so when we add the opposite, the result is 0. So let's see what this property is actually called. This is called the inverse property of addition. Once again, we're using addition, and we're taking the sum, we're adding a number and its opposite. So a number and its opposite, and that will equal 0. And once again, we've generalized this equation, or this property, when we have a and negative a, and b or negative b. And we also have, let's just leave that as c and negative c. Those are placeholders, variables, that are actually representing any number that we could substitute in for each one of those. And so a number and its opposite. And think of it again. Why the name? Well, I got to think of the name and what it's actually representing. Inverse. Inverse is kind of another word. Let's go with the pen. Inverse is kind of another word for opposite. They hold similar meanings. And so it's not necessarily called the opposite property of addition. It's called the inverse property of addition. And what we're doing is we are actually removing the value. We are taking the value of a number and we are adding its opposite, that same value, but its opposite. The negative adding the negative, or we're adding the positive, depending on which one we're starting with. And the result is going to be 0. And so this one, you're going to have to kind of remember the name based on the fact that inverse and opposite have similar meanings. And so if we were to go with examples, we could just think about loaning money again. If I were to borrow from you $100, I have a negative $100 that you are negative $100 because you gave it to me. But if I were to pay it back to you, I would owe you $0. It doesn't have to be a nice, pretty number. I can also have negative 4,319. And if I were to add its opposite, I would still end up with 0. And to highlight once again, doesn't matter if the negative's first or second term. We can reverse that, 5,360. And that is added to the opposite, and I'm going to put it in parentheses just to highlight that we're using the opposite and that we are still adding, okay? We still have a result of 0, and that is the inverse property of addition. Switching gears just a little bit, focusing on adding numbers with the same signs. So if we're going to add numbers with the same signs, we have to look at all the situations where that might occur. Well, the first instance may be adding a positive and a positive. Well, if we add two positive numbers, the result's going to be a positive number that is further to the right on the standard number line. So let's think about what that means. We talked about the number line in Unit 1.1, but let's just think about it. If we have a number line, okay, we got our number line, and we're only dealing with positive numbers in this case. So let's go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what this is saying is if I add two numbers that are positive, so let's just choose two of these numbers to add. So I'm going to add, let's say 2, and I'm going to add 5. Well, we know that 2 plus 5 is 7, but that 7 is located further to the right, okay? It's further to the right, okay? I have to move to the right from the 2 to get to the 7, and I have to move to the right to get to the 7 from the 5, so it is further to the right on the standard number line. Remember that as we move this direction to the right, the numbers increase in value. Okay, so if I add two positive numbers, I'm going to have a result. Okay, so let's correlate these two. So if I have two positive numbers, which are my numbers in green, the result is going to be a positive number, that's the 7, and it is further to the right on the standard number line. Okay, now let's think about what happens if we add a negative number to another negative number. Okay, you may already have an idea of what's going to happen here, but we're dealing with negative numbers, so let's put the 0 on this side, -1, -2, -3, -4, -5, -6, -7, -8, -9, and -10. Once again, let's choose two negative numbers. We'll choose -3 and -6. Okay, so here's my two negative numbers that I'm choosing. And -3 added to -6 is going to end up being a result of -9. And so the result is a negative number. And which direction did we move? Which direction is that -9 in relation to that -6 and -3? Well, it is further to the left. The result is further to the left on the standard number line, because as we move to the left, the numbers decrease in value. So left, the numbers decrease in value. So that is what happens, and that's a visual also of what happens. So let's go ahead and hit further to the left. That is a visual representation on the number line of what happens when you add numbers with the same signs. But what happens when you add numbers with different signs? So let's take a look at that. Adding numbers with different signs. Well, the only instance where you would have the addition of numbers with different signs is if you have a positive and a negative number that are added together. So let's draw our number line with the representation of numbers. Let's see, we drew them on the below, so let's stay with that. 0, 1, 2, 3, 4, -1, -2, -3. That's going to work. So let's choose our two numbers. So we have a positive number. We'll make our positive number. Let's choose +3. And we need a negative number. So our negative number, let's say -2. Okay, we don't want to choose -3 and 3 just because we don't want to necessarily use the inverse property of addition right now. So let's choose something different. And so this is the equivalent. So we're going to choose 3 plus a -2. Now notice this. This is important. This is a very important concept. The addition of a positive and negative number is the equivalent of subtracting the negative number from the positive number. So when we talk about addition in algebra, we are going to add positive numbers, and instead of saying subtraction a lot, we are going to refer to it as adding the negative. Okay, so adding the negative and subtracting are equivalent. They result in the same value. So just as a quick example, so if we have 3 minus 2, that is equal to 1. If I say 3 plus a negative 2, that is also equal to 1. Now the importance of this is that if we really focus on adding the negative, that gives us the ability to now use all of the properties of addition that we just learned. Remember, they didn't work. The commutative property, the associative property, they did not work with subtraction. It does not work with 3 minus 2. The commutative property does not work with 3 minus 2 because 3 minus 2 is 1. However, 2 minus 3 is equal to negative 1. Okay? That does not work with the commutative property. However, the commutative property would allow us to say negative 2 plus 3, where adding a negative, is still equal to 1. So we want to really highlight the fact that instead of using subtraction, we are adding a negative. And so let's see what the result is. Well, the result, in this case, we replace it on the number line. The result is 1. Okay, so the resulting is a number that is further to the left, okay, but is further to the left of the original positive number. So it is going to move to the left of the 3, which is the positive number, okay? And so we could say that it moves to the right of the negative, but a lot of times let's just use it in association with the positive number, okay? And then once again, I want to highlight the importance of this statement. Subtraction is considered as adding a negative number, and it is necessary to apply the addition properties of real numbers. So if we learn that subtraction is really adding a negative number, we can then convert to using the properties of real numbers when we simplify expressions and simplify expressions and solve equations, because we are adding. So let's look at example number 1. This is highlighting learning targets number 1.3a, 1.3b, 1.3c, and 1.3d. These are our properties of addition. And so what we're needing to do is match our properties with the generalized representations of them in equation form on the left. And so let's look at what is going on with this particular equation. And what we see is a number that is added to 0 maintains its value, or if you recall, what's that word that we said? Maintaining its value is the same as maintaining its identity. Identity. Okay, so take a moment to see if you can complete the others. I gave you the first one just as a beginning, so hit pause if you have not already. Okay, now let's look at the next one. So we have a plus b plus c is equal to A plus B plus C, but we have now parentheses that have been included. Well, we know that when we have seen groupings, that groupings are now associating two of the terms together. And so when we look at how these are being associated, and the value has not changed, and that is because of the associative property. So moving to the third one, so we have B plus negative B. So we're adding the negative, but we know that the negative is the opposite of the positive, right? And so which one of the properties dealt with the opposite of a number? And that would be the inverse property that states a number added to its opposite is 0. And so that does leave one property, which we could just quickly say, okay, these are the only two that are left, let's move on. But just as a refresher, when we say that A plus B is equal to B plus A, that is the commutative property. And remember that we are going to use the analogy of commuting to work from Lexington, or from Danville to Lexington, is the same value as commuting back home from Lexington to Danville. So it is very important that you remember the names of the properties and their usage, because you will have to be able to justify your steps as you begin to solve equations in the future. So that's example number 1. Example number 2. So this is going to highlight learning target number 1.3e. And so we're going to add the numbers and state the direction on the standard number line. The result will be relative to the two numbers being summed. And so when we look at the first example, so take a moment, and I'm going to let you hit pause if you have not done so already, and complete this example, and then I'll work through it with you. And so looking at the first example, what we have are two positive numbers. And so when we add two positive numbers, if you recall, adding two positive numbers means that on the standard number line, adding two positives will move further to the right. Now, that is just a generalization that's going to work for all positive real numbers. But if I want to check myself, I can say that 14 plus 1, or 14.1 plus 13.63 is equal to 27.73. And if I were to draw the standard number line, okay, and just in general, I would put 13.63 here. I also know that 14.1 wouldn't be a greater number, so it's going to be a little bit to the right. And if I were to have to place 27.73 on the number line, it would be way over here for 27.73, which is moving to the right. So that is a visual representation of what we can deduce just by looking at the numbers themselves and thinking about some of the rules we've already discussed. Okay, so I'm going to write this back in. Okay, so the next question. Negative 101.24 plus a negative 85.71. So the first thing we have to determine, are we adding numbers with same or different signs? Now we have to be careful because initial thought may be, oh, the signs are different because I have a negative and I also have a positive. But that positive is just representing the addition or summing the two. Inside the parentheses, notice that we have a negative 85. So we have a negative 101.24 and a negative 85.71. So we have these same signs being added. Well, in this case, we have two negative numbers being added. And when we add two negative numbers, we know that it will move to the left. The result will be to the left on the standard number line. So just to double check ourselves, we need to add the negatives together. And the result in this case will be negative 100. Oh, let's write over here. Negative 186.95, which is a smaller number than either of those. And we know that as we move to the left on the standard number line, the numbers decrease in value. And so we are correct once again. Finally, we have 32.31 plus a negative 57.12. And we have a negative. We have our addition of that negative. However, there is not a sign out there. So since there is not a sign that is shown, we can conclude that it is a positive. So we're adding a positive and a negative. So we are adding numbers with different signs. And in this case, we are adding a positive and a negative. And so when we look at the direction, we have to look at it relative to one of the two. Well, let's look at it relative to positive. Relative to the positive number. So the positive number is 32.31. Okay, so that's our positive number. So if we have 32.31, way over here would be negative 57.12. We're going to start here and figure out which direction our result will be when we add 32.31 and negative 57.12. So the result of those 32.31 plus a negative 57.12 is equal to negative 24.81, which on the standard number line would be between the two. We'll estimate there. And we have moved relative to the positive number, we have moved to the left. And so we can say that the direction that we move relative to the positive number is to the left. Relative to the negative number, we moved to the right for our result. And so those are several examples that highlight learning target number 1.3E. And this concludes our Unit 1.3. As always, please take your time to go back and review the notes. Make sure that you have a full understanding of all the concepts and all of the terms and terminology. Rework the examples. Become familiar with how they can be worked. And if you have any further questions, please ask your math teachers. We are all more than happy to answer any further questions that you might have. And as always, have a great day, and we all look forward to seeing you in class.